Information systems come under many different types of attacks. Organizations that rely on information systems need to take steps to protect their data and the systems that this data resides on to ensure that resources are available to meet the organization's business needs. These attacks can compromise sensitive data, violating its confidentiality. These attacks can compromise how transactions are performed, thereby compromising their integrity. And these attacks can also cause resources to be unavailable altogether to those users that rely on them in order to do their jobs. Accordingly, organizations need to take steps to minimize the possibility of these attacks succeeding. The first thing that the organization should do is determine what the actual threats are. Consider the sources of these threats and take steps to minimize the possibility that these threats can be realized against their information systems. Attacks can be technology-based or logical attacks, typically involving malicious software. Attacks can also result in physical damage being inflicted upon information systems, or also systems can be stolen. And then finally, a very popular technique that attackers exploit involves eliciting sensitive information from the users, tricking the actual organization's users into volunteering sensitive data. The organization needs to recognize what these are and take steps to stop them. The first area that we'll discuss as part of this effort to minimize the possibility of these attacks succeeding is in the area of system maintenance. Organizations should take basic steps to minimize the possibility of their systems being exploited. The reason why these systems are exploited in the first place is the result of different issues. The technology that is deployed may have vulnerabilities that can be exploited by an attacker. The technology, on the other hand, that is designed to deal with these types of attacks may not be properly configured or not effectively set up. Organizations may have the wrong policies in place, or policies that are not effective in addressing these threats and identifying how organizations should act to minimize the effects of these threats. And then, of course, there are those things that just cannot be predicted, which would be, of course, human error. Right? Certainly, there are attackers that will deliberately try to compromise systems, but the organization also has to deal with the possibility that users simply make mistakes. One of the most popular technologies in place today is TCP/IP. TCP/IP is the protocol that allows for users to access websites on the internet, and it's also the basis of technology used on private networks. TCP/IP was developed back in the 60s, and it was designed to be used on government systems. These systems were expected to be private, and these systems were expected to provide reliable functionality, even though the network that TCP/IP was running on had actually suffered a catastrophic event, specifically a nuclear attack. Therefore, TCP/IP as a service is focused on functionality. Unfortunately, this focus on functionality ignored the need to incorporate security into its design. There are many different vulnerabilities within the functional aspects of TCP/IP that can be exploited. Similarly, operating systems that users rely on to enhance their capabilities, get their work done, whatever it might be, are also designed for utility, for service, for functionality. Accordingly, if a system is meant to be functional, security is secondary. And oftentimes there's a trade-off between functionality and security. Every time a security process is applied to a business function or business operation, that function or operation takes a performance hit. Its capability is somehow limited. That is the unfortunate side effect of applying security to an operational environment. On the other hand, if this function or operation is unavailable as a result of an attack, then the organization has suffered an even greater loss. Network equipment is also designed to transmit data as quickly and as efficiently as possible. The same scenario applies to network equipment. The fact that they're designed to transmit data and therefore are not necessarily focused on securing data. Consequently, the infrastructure upon which TCP/IP and the operating systems of our devices run on can be compromised. So there are again the technology in an attempt to expand our capabilities and add additional services can come under attack. Now, the technologies that are available have the newer technologies that are available have security built into them, but at the same time they are designed to be to be useful to the user community. Consequently, configuration of these systems can represent weaknesses that attackers can exploit. For example, certain systems include default passwords. Default passwords have either known, recognized passwords that anyone who's ever worked on the system would have access to, or sometimes they have no passwords at all. Similarly, users, when left to their own devices, regarding password selection, may pick those passwords that are easy to remember. Unfortunately, if a password is easy to remember, then it is also easy to guess. There are certain internet services that are available that are meant to be, again, user-friendly, easy for users to take advantage of, and consequently they can be exploited by a knowledgeable adversary, a knowledgeable attacker. Oftentimes devices are intended to provide what is described as a positive out-of-the-box experience. In other words, when the user acquires this, this technology, this device, such as a wireless access point to be used at home, the goal is to make this wireless access point functional and useful as quickly as possible, which means that users typically have a minimum set of configurations that they have to perform. And of course, these minimum configurations do not typically include security. In order to get the system functional, the goal of the vendor is to make sure that it can be used easily by their customer base and not necessarily used securely. Similar to access points, other devices have the same. Other network devices have the same issue. Again, they are designed to provide functionality with a minimal amount of protection. With a minimal amount of effort, and accordingly, there is very little protection on such devices as switches and originally hubs. Attackers use different types of malicious software to exploit systems as well. Again, if a system doesn't have the appropriate controls in place, it becomes susceptible to malicious software that is waiting for them on the internet. Two very popular examples of malicious software are Trojan horses and viruses. A Trojan horse is a program that a user downloads thinking that they're getting some free service or free utility or free application. For instance, somebody downloads what they think is a free game or a free screensaver or some other useful little utility. Unfortunately, running in the background of this free utility is malicious software. The The most common example of Trojan as malicious code is called a remote access Trojan. Essentially, a remote access Trojan, or a RAT, allows for the attacker, the creator of that Trojan, to take control of that system. Once the Trojan infects compromises a system, it allows for the attacker to take control of that system and use it for whatever they want. Viruses, on the other hand, simply infect a computer and inflict some sort of damage on it. The way that a virus does infect a computer is that it has to somehow gain access to that system, which means that it involves the user's interaction to allow the virus to infect their computer. A very common method today is to attach a virus to an email message and send it to the unsuspecting user. The user receives this message, they open the attachment, and their system becomes infected. And these, again, are examples of, these could be the result of systems that are not properly protected after they've been deployed. Other areas that cause problems are the actual defined security practices or policies of an organization. It's understood that organizations should have some sort of an acceptable usage policy in place to determine what activities can be performed by the user when interacting with corporate systems. And again, the best example here is using the corporate connection to the internet by allowing the users to visit unauthorized sites. They may visit a site that ends up attacking their computer, causing the system to be compromised. Now, other organizations don't have the appropriate policies in place to protect sensitive information related to their customers or even the employees. And if a customer's information is inadvertently accessed by, or deliberately accessed by, an attacker, then the organization, could be held liable for not taking the appropriate steps to protect the privacy of sensitive data. It's also recommended that organizations properly implement this principle of separation of duties. Separation of duties is essentially going to allow divide responsibility for two individuals to be responsible for one system. It's to prevent one person from being able to single-handedly compromise a system. If one person has too much authority, that excess authority would allow them to compromise a computer. Separation of duties means that one person is responsible for the, defining the input to a system, and someone else is responsible for managing the output. One person is responsible for creating user accounts, and somebody else is responsible for assigning permissions to those user accounts. One person prints the check at a bank, and someone else signs the check at that bank. Okay, these are all examples of separation of duties, and oftentimes organizations will not enforce this principle. Consequently, systems are abused by inside users. Organizations should also have an effective password management policy in place. Password management means that the user has to follow certain criteria to create a password before being able to use that password on their user account. Again, when users are left to their own devices, they will probably pick a password that is easy to remember. And again, in an effort to make their systems easy to use, users create this vulnerability. Now, service level agreements should be worded in such a way that they protect the interests of the company. Typically, companies have contracts in place or agreements with outside service providers, and the terms of these contracts should be in such a way that they Again, protect the interests of the organization. For example, if the service provider somehow fails the company, then the service provider should be liable for some sort of compensation to the company. Finally, organizations do not take the appropriate steps to properly sanitize data, specifically the media that data is stored on, either hard copy or electronic media, before it is disposed of. Organizations should have the appropriate procedures in place to ensure that if anyone gains access to this media after the fact, they would not be able to use the information that is stored on that media. Users, unfortunately, are human, and therefore they make mistakes. Again, these mistakes occur because they just do. An accident may occur, or users are unaware of their responsibilities, and therefore they don't take the appropriate steps to secure their the systems or the data that they work with. On the other hand, there may be a case where an organization puts too much responsibility on the shoulders of its administrators, and consequently, because someone is overloaded, they let a mistake get away from them, causing the organization to suffer a loss. And finally, organizations' information systems can come under attack. They can be attacked by individuals intent on causing the owners of these systems some harm. These malicious events can occur as a result of the attacker lying or impersonating a user or a service person with a requirement to gain access to a system. The deliberate attack could come from someone who is an ex-employee. Okay? The attack could occur when an internal user has gained access to a system that they normally do not have permission for, and also attackers, again, as an act of revenge or whatever it might be, will oftentimes launch a denial service against an organization's systems. A denial service means that computer will be compromised to the point where it is unavailable to legitimate users. Also, social engineering attacks involve the attacker, gathering sensitive information about a given individual in an attempt to commit fraud by masquerading as that individual. So again, there are many different things that allow these security incidents to take place. It's up to the organization to take steps to minimize the possibility of these events occurring. One technique would be to secure the operating systems that the users rely on in order to do their jobs. And there are many different ways to do that. One technique is to modify the settings of the operating system so that unnecessary services do not reside on the computer. For example, games, or these external utilities that allow for external connections to service providers. By removing these, the administrator can reduce the possibility of a breach taking place. Another very important recommended procedure is making sure that all systems have the latest and greatest updates. There have been studies that show that if the administrator of an organization's systems properly updates the systems that the organization owns or is responsible for, they have the possibility of preventing over 90% of the various attacks that actually succeed. In other words, the vendors know about these vulnerabilities before the users do, and consequently they make these updates available, which the users of these systems should apply in a timely manner. By applying updates again in a timely manner, the organization can reduce the possibility of these attacks, of over 90% of these attacks from actually succeeding. Now, there are different ways to apply these updates. They're called patches, they're called hot fixes, maintenance releases, and there are very subtle distinctions between these that aren't really worth talking about. Oftentimes, a collection of these updates and maintenance releases are combined into a collection, typically referred to as a service pack. However, the updates are made available, it's understood that the organization is going to take full advantage of implementing them. Another important update process would be to ensure that the BIOS running on the computer supporting the operating system is also current. The updating the BIOS is a little bit more interesting than simply applying a patch to the operating system, but at the same time it is something that is recommended and something that should be performed very carefully. If this is not performed the way that it should be, the BIOS could become corrupted if an error is experienced during this process, and the system would be in big trouble. But again, the BIOS needs to be updated along with the various applications and operating systems that the apps are running on top of. They need to be updated as well. There are different ways for organizations to secure the actual programs running on these systems. In addition to focusing on the BIOS and the operating system, the actual user programs should be protected as well. Now again, there are different ways that these systems can be compromised. Again, a user's application may rely on an additional module that enhances its functionality, but it may also create a vulnerability that an attacker could exploit. Another problem often results from applications that have not been properly configured. As programmers create these applications, they write these applications. The goal again is to use this application to solve some kind of a problem, okay, to meet some sort of a demand or resolve some sort of a security issue. The downside of this is that in an attempt to focus on and while programmers are focusing on solving these problems, they don't spend as much time as they should on protecting their application. Again, when security is incorporated into a program or is applied to a device, it is it's going to affect the capabilities of that particular device. Another deliberate method of compromising a system is injecting malicious instructions or malicious code into these applications. There are many different types of injection attacks. SQL injection attacks is a very popular example, but essentially it involves issuing instructions to the target system, and these instructions cause the application to perform in some unauthorized manner. So injection attacks are malicious instructions issued by bad guys to exploit some vulnerability in an application, causing it to function improperly. In an attempt to resolve this, organizations can take advantage of different techniques. For instance, they can acquire their software, their applications, only from trusted sources, only from recognized vendors. And also the programmers who create these applications should take steps to minimize the possibility of these applications being exploited. This involves including security into the design of the application so that the attacker can't issue malicious instructions causing the system to perform in some unauthorized manner. Baselining is in this context is the practice of defining a minimum level of security and performance requirements that must be met by a given system. And again, a minimum level of security would reduce the possibility of these very basic attacks from exploiting the system. We mentioned the importance of keeping operating systems and applications current, along with the BIOS. So an organization should implement an effective patch management program to ensure that all of the systems do in fact have the latest and greatest updates. Similar to application hardening is secure coding practices. Again, this is something done by the programmer in an attempt to remove those vulnerabilities and other problems that could be exploited by an aggressive attacker. These individuals will acquire a copy of the application, reverse engineer its code, and identify a breach that they believe that they can exploit. They then write an attack that exploits that particular breach, and then they make that application available on the internet. To combat this problem, it's understood that the various the various companies that produce code incorporate these secure coding practices into their development processes. In addition to suffering from logical attacks, computers can come under physical attacks. Physical attacks can involve in systems being damaged, resulting in a denial of service, or systems being stolen, also causing services to be unavailable to users. In an attempt to minimize the possibility of adversaries actually physically coming into contact with systems, an organization should have an effective physical security access control mechanism in place. The best thing that can be done is to ensure that users are properly identified, perhaps by using an ID badge or some other mechanism, producing their credentials when they attempt to gain access to a building. Right? The users can be expected to carry with them security tokens or smart cards, which are used to in conjunction with a service running on the information system to allow someone to gain physical access to a building. Similar to that, physical tokens, proximity cards, common access cards used by government personnel. These are all mechanisms by which a user can be expected to validate their identity to the system before they gain physical access to that building, that facility. Another highly successful technique for controlling physical access to a facility is biometrics. Biometrics is the practice of scanning some physiological feature of a user and then maintaining a sample of that scan on the system. Every time the user wants to get into the building, they would have that same physiological characteristic scanned, and the capture of that scan is compared to what is stored on the system to authenticate the user. Biometric systems tend to be very accurate, they tend to be very expensive, but they're also virtually impossible to defeat. Here we're looking at an example of some sort of a card reader. If this were a military system, if this gadget were attached to a military system, the card that would be placed in there would be the government employee's common access card. And again, they're used in commercial applications as well. Here we're looking at an example of a finger scanner. The user, to authenticate themselves to the system, would be expected to drag their the registered finger, right, over that opening in an attempt to authenticate the identity of that user. Now, as I mentioned before, biometric devices will take some physiological scan of the authorized user or employee and maintain that information on the system. And then each time the user needs to be authenticated, they would submit to this to this scan, and then the second scan would be compared to what is stored on the system for that user. And as you can see, it could be the scan of a fingerprint, like that reader that we just saw a picture of in the previous slide. Okay? It could be a scanner that examines the characteristics of the entire hand, the entire palm. Right? There are eye scanners that look at the blood vessel structure in the back of the eyeball or the colored part of the eye that can be seen without a specialized scanner. There are other biometric techniques that require the user to do something. Okay? They can speak their name or some sentence into a particular system, and it'll compare what is captured there with what they have on record for that person's voice. And then signature verification is when the user actually signs their name across an electronic pad, and then that captured signature is compared to what is used or what is stored in that system to determine if the user can actually use that system. Now, these second two techniques, voice verification, signature verification, and DNA scan, are a bit over the top. Typically, an organization is going to rely on a finger or a hand or an eye scanner to implement biometric controls. In an attempt to prevent users from gaining physical access to resources, organizations can use different techniques to prevent someone from gaining access to a building, as well as identify an intrusion underway. Now, putting locks on doors and controlling access points is a great way to control whether or not somebody can get into a building. A man trap, for example, is an access point that includes two doors, and these systems can be monitored by a camera or by a guard. They can have scales that people have to step on to make sure they're not taking a souvenir home with them when they leave, and they can be. There are many different features that can be incorporated into a man trap. The only common feature in a man trap is that the two doors cannot be open at the same time. It's either one door or the other door, but never two doors. Locks, man traps, and fences will slow down or prevent someone from gaining access to a building. If someone is responsible for monitoring the perimeter, such as a security guard, well, that monitoring process will be facilitated by the deployment, the strategic deployment of lights to make sure that the entire area is covered. Guards can also use cameras to monitor the environment as well. Also the system should keep a record of all of the activities, of who comes, who goes, if someone attempted to log in but failed using electronic technique, those need to be considered as well as part of this activity tracking or event logging. All of these techniques can work in conjunction together as part of an organization's physical security program. There should be controls in place that will prevent an attack from happening, and there should be other controls that can be used to identify that an attack is underway and to discourage someone from doing so in the first place. Now, there are different ways that access points can be secured. The ever popular lock and key is a good one. More sophisticated systems rely on a combination, such as a cipher lock. A cipher lock expects the user to enter in a particular code, for example, 1, 2, 3, 4, and once the proper code is entered, the user can open this door. These systems also take advantage of what is known as a hostage alarm. A hostage alarm is a code that when entered into the system, it will open the door, but it will also alert the guards that somebody is being forced to open the door. If somebody's, an authorized user is forced at gunpoint, for example, to enter into a code to open the door, well, they can enter in a set of numbers that will generate an alarm. This is, again, called a hostage alarm. A man trap, again, is two doors that work together, and the only common feature in every man trap is that both doors cannot be open at the same time. It's either one or the other, but it's never both. Again, if the whoever's monitoring this man trap doesn't like what they see in the man trap, they can lock the person in until additional help arrives. So man traps are used in highly secure environments to control access to highly secure environments because they require that somebody monitor this door to to control access. We described different types of attacks that can physically compromise assets. The next section is going to describe the different examples of malicious software. There are different types of malicious code. You can see some examples here on slide 24. One of the original examples of malicious software was a virus. A virus is a program that attacks a computer in different ways. The only requirement of a virus is that it has a mechanism by which it can gain access to a computer and cause it to suffer a hit. Now, which means that viruses rely on the help of your user community to find new systems to infect. A worm, on the other hand, is an attack program that has its own search engine incorporated into its code. And it uses the search engine to find active hosts, typically by pinging, in order to infect those systems, to attack those systems. And some of the most damaging attacks on the internet were worm-based attacks. Now, these attacks were so prolific and so aggressive, the only thing that slowed them down was the available bandwidth of the internet. We talked about a Trojan horse a little bit earlier. Again, it appears to be a useful program, but in reality, it is doing something bad to your computer, typically allowing someone else to take control of your system. A logic bomb is a program that resides on a computer and it will activate when some criteria is met. Okay, when it infects a computer, it sits there quietly, dormantly on the system, and then when a date shows up or some other criteria is met, the logic bomb activates and it attacks the system. A rootkit is a specialized attack that allows an attacker to take control of a system much like a Trojan horse does. However, a rootkit tends to be a little bit more subtle in its effect on the target system. It involves overriding some of the files and services in the operating system, but the effect is the same as a remote access Trojan. The bad guy's taking control of this computer, typically without the owner of the system knowing about it. Spyware and adware are techniques that are used to monitor activity on a network or to steal information off of that network and transmit to some remote source. Some examples of adware are legal. Spyware is always stealing something from the target system. A keylogger is a utility that is used to capture keystroke information from a system that has been infected with or is configured with a keylogger or keystroke logger. The goal here is if an attacker uses a keylogger, they're trying to capture logon information, such as a username and a password. On the other hand, an administrator can use a keylogger to investigate the activities of a user perceived to be doing something wrong. A botnet is a collection, a network of compromised systems, generically referred to as bots, and a botnet controlled by the attacker that created the botnet, oftentimes referred to as a bot herder. Okay. The bot herder can direct the botnet to attack different systems, to send out spam, to crack an encryption key. Many different attacks are available to someone controlling many systems as part of a botnet. A backdoor is a method by which someone gains access to a system. Essentially, they are bypassing the existing controls in order to get into the code of the system. These can be placed there by the actual developer, or they can be they can be the result of an attack, such as a Trojan horse attack or perhaps a rootkit attack. Drive-by download means different things to different IT users, but essentially what it means is if somebody accesses a particular computer, it will execute a script that attacks that computer, either to steal information or be uploaded onto that computer, whatever it might be. So there are, again, many different ways to execute a drive-by download. A zero-day attack or a zero-day exploit is a technique where or it's a condition, I should say, where the attack is so new that even the antivirus vendors have not had a chance to define some kind of a fix for that, for this attack because it's so new. There's certainly no signature for it, and there's no fix for it. So that's that's the downside of a zero-day attack. The most popular intrusion detection system is a signature-based system, which means that the system maintains a list of known attack signatures. A zero-day exploit will get around one of these types of controls. Now, a very popular mechanism for attacking software is through the use of malicious software. And depending upon how sophisticated the attacker is will determine what effect this malicious software will have on that user's systems. Okay? At the very least, it will have some minor damage. On the other hand, it can affect the organization at a much larger scale. It depends on the scope of the malware to determine what effect it's going to have on a computer. Yeah, at the very least, it's going to slow systems down. There'll be funny things on the screen like "ha ha ha, you've been pawned." On the other hand, they may escalate the privileges of the attacker after gaining access to the system, and they may also perform attacks against the data stored on the system. Whatever it is, okay, if it's a system that belongs to some organization that relies on its reputation to attract business, well, this type of an attack is going to have a very negative effect on that that organization's reputation in the marketplace. There are many different ways to address malicious software. Organizations can deploy a host-based solution. A host-based firewall is one that runs on the computer itself and is typically bundled with some other service. Antivirus software is another way to control access to the private network from the public domain. Again, if it's an antivirus software program, it probably involves signatures, the attack signatures being updated. And there are other more specialized attacks against antivirus software, or I'm sorry, anti-malware. For example, a user may install anti-spyware software on their computer to make sure that nobody's reading their mail or capturing information and sending it to some location. And then another recommended practice is to block all pop-up windows. Okay? Again, these are typically malicious and lead to no good for the owner of the network who follows them. Now, there are different ways that viruses can be recognized. The first one I already mentioned. The first one is where the vendor creates a record of all known attacks, and they create an attack signature for each known attack. This is what is distributed to, for example, anyone using an IDS on a regular basis from the vendor, right, from the antivirus software vendor. Now, another technique involves scanning the environment, looking for anything that appears to be out of the ordinary. Heuristic scanning means that the system is looking at a sequence of events that may recognize a pattern or may represent a pattern that is recognized as a particular attack method. Right? Organizations can take steps to identify rootkits that are deployed on their respective systems. Right? This involves scanners, as we were talking about a little bit earlier, but some of the newer antivirus software has trouble finding these newer malicious code examples because again, they're performing scanning, but rootkits are well hidden. So that's the problem with removing a rootkit from your system. A lot of times the user doesn't know if it's completely gone, and due to the panic effect, they simply blow away their whole system and start over. Sandboxing is something that is specific to web browsers and relates to the Java applets that are downloaded into the browser. When one of these applets shows up, it is localized to a sandbox, which is a range of addresses in a particular operating system. And again, it was this is an effective technique for localizing the effects of software on a real organization's network. On the next slide, you're looking at different examples of anti-malware applications. Some of them perform multiple tasks. They provide, for example, firewall services, scanning, anything that that can be used to protect a system from malicious software. So these are, that's what all of these are describing here. The last thing we want to talk about in mitigating threats is this whole idea of social engineering. Social engineering exploits what many consider to be the weakest link in the information security program, and that, of course, is people. Okay? The social engineering, as you can read, is going to be played against a target in an attempt to get this person to volunteer some sensitive data. Right? As the slide reads, it exploits the the inherent trust that people might have with other individuals, and if this other individual is starts telling a story about how they've had a bad run of luck or whatever it might be, and the only thing that's going to solve all the problems is to gain full access to the main server. Right? And yeah, as the slide reads, it's just some story that the attacker is telling. Some of the newer ones are becoming more. They're getting better, right? They're very clever in that they will involve some kind of a notice encouraging the user to follow a link to that notice, at which point the attack takes place. Now, there are different reasons why hackers do the things that they do. They commit. They steal information about a user to commit fraud. They attempt to break into networks. Right? They will perform corporate espionage on one another, and at the very least, they can also throw in a denial of service, causing the network to be unavailable. There are different ways that social engineering can be executed. The first method, as you see, is what it sounds like. In this case, the attacker is literally going through the trash, looking for account information, password information, could be banking information, any personally identifiable information that is found in a dumpster is more often than not fair prey, meaning that somebody can take it. On the other hand, if they use that to commit some sort of a crime, then dumpster diving then becomes illegal. But it's not the act of going through the dumpster, it's the act of using that information that you found in the dumpster. Next we have the evil twin attack. The evil twin attack is an attack launched against wireless networks. The evil twin is is an access point that has the same exact settings as the target AP. However, the only difference is that the signal on the evil twins antenna is cranked up to be 3 times stronger than that of the target antenna. And so somebody logs in, they provide their username and the password, and now of course it doesn't allow them to log into the evil twin, but the bad guy captured it anyway, and now the attacker is using it to break into another system. A hoax is the digital equivalent of a chain letter. The idea is that somebody sends out this outrageous message about how everything that they do will help them save the world. It describes some terrible thing that could happen, and only this person can assist in resolving this issue. Again, it's a chain letter. Okay? Again, hoaxes should be discarded. I recommend that if anyone thinks that they got a hoax, they should simply grab a copy of that message and then put it into Google and do a search on it and see what comes up. Chances are you'll find reference to that hoax in some places such as Snopes.com. Snopes is Snopes, Snopes.com. Okay, attackers, social engineers can impersonate as users. They can perform a variety of attacks, and of course, it's up to the victim to recognize this. Social engineering also relies on phishing and farming, which is sending email messages to a particular set of users in an attempt to lure them to a website where they will be attacked. Now, shoulder surfing, that's when somebody's standing behind somebody else, looking over the shoulder, watching them enter in their PIN number, or to an ATM, or some other typing their password in, something like that. Skimming is the act of placing this device on the key portion, or the card portion, I should say, of an ATM, and then when a legitimate user puts their card in, the skimmer captures that data, and now the attacker is going to use that data to masquerade as this person to break into their bank account. Spam is unsolicited commercial email, or it's just junk that shows up. Of course, it's up to the owner of the system to filter this type of traffic hitting their system. There's also spam for instant messaging applications. Again, an unsolicited message, always selling something, and it's always bad if you decide to pursue it. Tailgating is a technique that is used to get through a security checkpoint. The attacker follows a legitimate user through the door or past a security gate, pretending to be with the authorized person. Now, vishing and whaling are techniques applied to phishing attacks launched against individuals. Vishing is short for voice phishing. Voice phishing means that the recipient of the attack gets they get one of these robocalls, and the robocall directs them to visit their website. Visit the website of their bank, and please enter your credentials to make sure that they still match. Okay, or something like that. So voice phishing is a voice-activated attack using robocall in an attempt to compromise the target system. And then whaling is the practice of socially engineering a highly visible celebrity, a president of a company, a celebrity, those types of things. So vishing is voice phishing. Whaling is focusing a social engineering attack against a particular user. Now, what's the best way to deal with social engineering? Well, it is challenging. This is probably one of the most devastating types of attacks that can be launched. The best thing that the organization can do is perform an appropriate level of user awareness and training to help the users understand what a social engineering attack is, number one, and number two, what they can do to defeat that attack. Of course, it's up to the organization to communicate this information to the various users and explain how important it is. Right? Of course, which is going to be driven by how many times social engineering attacks succeed against this particular organization. So yeah, the users have to understand how to recognize these attacks and what to do in response to them if they are socially engineered, and they need to understand the level of priority based upon what this social engineering attack is related to. Okay? Now, everyone needs to understand what social engineering is, and everyone needs to understand that they have to be very careful. Of course, the best way to support social engineering attacks is to have an effective policy that will describe what is considered to be unethical activity and what would actually entail being social engineering. Okay? So again, users have to recognize social engineering so that they know, how to properly respond to it. An example of a social engineering attack, of course, is phishing. Phishing involves the attacker masquerading as a legitimate user, sending these specialized email messages to a select set of users. Okay? So the basis of phishing is an email being sent from a trusted sender. Now, this whole concept of trusted sender is really driven by how naive the recipient really is. Some of these places are rather ridiculous. I guess they just don't understand that people actually read these things to identify that, oh, gee, that's not good. I should discard that. So yes, phishing can be done via email. Spear phishing is focused phishing attacks launched against a specific set of users. For example, all the users that happen to bank with B of A or Wells Fargo or whatever. Phishing attacks will attempt to gain access to personal information in an attempt to perform some sort of identity fraud or identity theft. Now, when someone receives a phishing email, they need to look for different things. For example, they should look for the fact that, this is describing something for which there is no cure, or they still don't have a cure for it yet. You should look for messages that have poorly worded grammar. You should look for messages that are all in uppercase and use lots of exclamation points. Okay? Again, that's probably some sort of a phishing attack, or even worse, some kind of a hoax. So again, the users have to be trained to look for these hints or these clues that will tell them that, yeah, that's probably a piece of junk. Another mechanism, again, grab a copy of either the title of the message or some part of the body of the message and do a search on it. And again, like I said earlier, it will probably take you to the this website called Snopes.com, where it can be validated. It's important that the filters used in a corporate environment have the appropriate settings in place to filter unauthorized traffic, and of course there could be one done at the corporate level as well. So filtering for phishing attacks either at the workstation or the network level is highly recommended. As I mentioned, spam is unsolicited commercial email or unsolicited bulk email. It's all the same. It can be done at the PC level, which is the most common example. It could be done at the workstation level as well. But whatever it is, it should be ignored. Okay? This is a fairly aggressive number. 95% of all the traffic is spam. I wonder how fast it would be without all these spam messages in the way. So what can we do to protect against spam? Well, again, filtering, doing content filtering is going to identify a message as a as spam. Also, if you receive a message and it invites you to unsubscribe, do not unsubscribe from messages that you know to be spam. When you do, all this does is it gives the attacker a legitimate IP address that can be added to somebody's botnet or whatever it might be. As you use multiple accounts, if you really need to connect to some website that you know you're going to be getting junk from for the rest of your life, but still you want whatever's on there, well, you can use a multiple account, a unique account. You have one account for all of your business dealings and your day-to-day activities, and then you have another account available to buy that latest sweater from the latest product from some online service. Again, you want to use these multiple accounts in such a way that, if somebody starts sending you a lot of spam, that's okay. It's not your primary account. It's a secondary account that you use for online shopping and other things. Now, another source of social engineering attacks are social networks. Social networks represent great sources of information for bad guys to find out stuff about potential targets, number one. And number two, certain information, sensitive information, should not be disclosed from should not be posted on social networks in the event that the sensitive data may become public knowledge. Right? Similarly, social networks are a great way to distribute malicious software, especially if the malicious software is coming from a trusted source, a friend from Facebook. Now, in order to prevent malware distribution from personally identifiable information being stolen from these social network accounts, it's recommended that whoever sets up a Facebook account or a LinkedIn account or whatever, right, have a strong password. If a bad guy can guess what this password is, then a bad guy can break into this account and pretend to be the owner of that account and commit fraud and send other unpleasant messages. An organization's network environment comes under many different attacks. They can be logical attacks originating from the internet or from an internal user. They could be physical attacks that involve the attacker placing their hands on the network equipment, or they could be social engineering attacks which play on the emotions of people in an attempt to elicit sensitive information from them. All of these need to be addressed as part of an organization's information security program, with the goal being to minimize the attack surface that can be exploited by any one of these malicious processes.